Hello coder, welcome back to my channel. Today, we are going to unpack a very interesting and interview favorite problem. Problem is counting unique palindrome subsequence of length 3. So basically, this is a problem that teaches you pattern recognition, string analysis, and efficient thinking. So stay tuned till the end because I will explain every single line, every single step in a very deep and simple way. Okay, so let's get started. Here is the final code. Okay, so in line number 1 and 2, we start by creating a class solution and a function that take the input string guess. Okay, in line number 3, we create a list name first with 26 position, one for each lowercase English letter from A to Z. So question is why 26? Because the problem states that the string contains only lowercase letter. Every entry is initially -1, meaning we are not seeing that character yet in the string. For example, first 0 corresponds to A and first one correspond to B, something like that. That means first 25 correspond to Z. In line number 4, we also create another array called last. Here, we also create another array called last. This will track the last occurrence of each character. At the end, first see where that character first appeared, last see where that character last appeared. These two arrays help us understand the outer character of a palindrome of length 3. So basically in line number 6 to 11, we are tracking the first and last occurrence. Wait. Yes. So this, okay, last occurrence. Okay. Now, we loop through the entire string I. Here for I, here I is index 0, 1, 2. Okay. 0, 1, 2, 3, 4, 5, 6 long last. Okay. Ch the actual character at that index. Then we compute idx is equal to odd ch minus odd a. So idx is equal to odd ch minus odd a. So this convert the character into a number between 0 and 25. For example, ch is equal to a, so idx 0. ch is equal to c, idx 2. ch is equal to z, idx 25. Okay, so the now logic is first occurrence. So first we check for first idx is double equal to -1 and first idx is equal to I. This means if this is the first time we see the character stored in position and last is last idx equal to I, we always update the last occurrence because every time we see the character again, it becomes the new last position. At the end of this loop, first C is the earliest index where character C appears, and the last C is the latest index where character C appears. And in line number 13, that is answer 0, we initialize our answer. This will count how many unique palindromic subsequences we have found. So the main palindromic logic is what? That is a palindrome of length 3 looks like x, y, x. Here, x is a same character of both sides. Y can be a character in the middle. And so for every character from x from A to Z, we need the first position of x, the last position of x, and the all character that appear between these two positions. So from line number 15 to 21, okay, let's break down. Okay, so step 1, loop through all characters. For C in the range 26, okay, we examine each character from A to Z. Now step 2, that check if that character appears at it's at least twice. This condition means the character was found in the string at least once. The character appears again and again later in the string. That is, it has two positions, one at the beginning and one at the end. If a character appears only once, it cannot form x by x. Now, step 3, that is extract character in the middle. That is line number 18. Here we take the substring between the first and last occurrence of that character. For example, S is equal to what? A B C A. So your character A. So A B C A what? A is equal to 0, A is equal to 1, then B 2, C 3, A 4. So first A index 0, last A index 4, and the middle substring A B C. Here we convert it to a set A B C. Why a set? Because we want unique palindrome. Okay, each unique middle character Y form a unique palindrome, that is AYA. So if the middle set has size 3, we found 3 unique palindrome AAA, ABA, ACA. Now step 4, add how many unique palindrome found. Here is the line number 19, and plus is equal to len middle. So here, if the middle set contain y unique character, then we add k to the answer, because each unique character y form x by x. In line number 21, that is return ans. Here we return the total number of unique palindromic subsequence found. Why this work perfectly? Okay, so this solution is brilliant because it avoid brute force. It doesn't check every possible subsequence. It reduces the problem using the structure of the len 3 palindrome. It processes each character only a few times. It works in 0 and time, even for larger string, that is 1 lakh character. This is exactly the kind of optimal solution interviewer love. Okay, so what is the conclusion from this question? So in conclusion, we solve this problem by realizing that a palindrome of length 3 has a very strict structure. The first and last character must be the same. We used this pattern to avoid unnecessary computation and counted unique palindromes efficiently using character position and sets. So this is clean, powerful, and optimal approach that works perfectly for large input. Okay, so thank you so much for watching this video. If you enjoyed this deep explanation, please give a like, subscribe this channel, and comment which question you want me to explain next. Your support motivates me to create more high quality explanation. See you in the next video, and as always, keep learning, keep coding, and keep improving. Bye bye.